Okay, I'm going to walk you through completing data table 1, where you have the collected data for the linear regression method for the percent by mass sodium chloride. I just titled this one for solution A. I don't know if this is the solution A that you actually used, but the procedure will be the same once you put your data into your table and do the calculations that way. So to first part, I have the mass of sodium chloride that I used to prepare standards, and then the total mass of solution. We use percent by mass because it doesn't depend on temperature, so it doesn't change like molarity does. So a lot of times we'll use this as a concentration. So remember that just equals the part of the solute divided by the total mass of solution times 100 to get your percent by mass. So here you would just type in this equals the solute divided by solution, and then times 100, and obviously that's going you can't divide by 0, but it's going to say that, right? So on this one you're just going to have to type in a 0 if you try to do a formula. So we're just just to show you how that works, you can't divide by 0. But so that's just your distilled water anyway, so it doesn't have any sodium chloride in it. So this cell though will equal your sodium chloride divided by your total solution times 100, and then this one is going to have to be reported to 2 significant figures because your mass is only good to 2 decimal places, and that happens to be only 2 sig figs also, so you have to reduce that decimal till you get to that, and you can repeat that for all of those. Now right here you'll see that's 3 sig figs, that's 3 sig figs, and that's 3 sig figs, so that's all good, and so is this one. Both of those are 3 sig figs. So that's your concentration of sodium chloride in percent by mass for each one of your standards. And I'll just kind of highlight that. And then here's where I took aliquots of each individual one, and maybe just different. I measured out the volume and then recorded the mass to 2 decimal places from the balance, and then I need to calculate density for each one of the substances. Now that should increase every time because I'm adding a higher concentration of sodium chloride. So we'll start out with our density of the distilled water, and it's just going to equal the mass divided by the volume. So just click on the appropriate cells for that and enter, and 3 sig figs on this one, so there's 3 sig figs, and repeat that calculation, and then check each one for sig figs, right? So they should all be 3 and those are all 4, so I need to select those and decrease the decimal for those. So there I have the density, and it does go up every time, so I don't know if that goes up in the right amount or not, but that's okay. Like I said, a lot of it's just hand piece data, but the procedure will be the same for you. So now I have density, and I'll highlight that just so we can look. Those are the 2 we're going to look at for our calibration curve, because remember, calibration curve is when you compare the concentration of something to some other variable that's changing, and since you control the concentration, that's going to be your independent variable because you produce those standards, and then these numbers over here will be what happened as a result of you increasing concentration. The density increased, which makes sense. So this part, the first part I'll do here is I'll show you how to start the graph, your linear regression, and then how to use that, and then we'll go on from there with more calculation. So I'm going to I'm clicking over here somewhere just for the time being. I'm going to insert, and then I'm going to go to my charts area here, and I'm going to pick this one here that's a scatter plot. So I click insert scatter and no lines, just like that. So you kind of have a, just a blank slate for now to start out with. Now there are ways to highlight your data and plot it and things like that too, but I want you to do it this way first, the first time. So you have this, and I want you to you can right click in there, or you can go up here to select data, so up at the top. So I'm going to add a series. Now I don't necessarily have to name it, but I want to choose my X values, which is my independent variable. So I click that, and I am going to choose my concentration because that's what I controlled. Go back and just click that, and the Y values that go with those data points be right there for density. And then I click OK, and I'll just click OK again, and I have a sort of a linear graph here. You can tell that it's a little off, and that's on purpose. Yours probably should be a lot better than that. So that's how you set up your scatter plot. And then you need to format a few things before you keep going. So the first thing that I want you to do is actually start to format your graph. And I think the way we'll do that, we'll just click on each individual part for a second. And first you choose the title here. There are a few different ways to put a title on your chart, but this one is going to be Figure 1, and I'll just put a period, and then I'll tell what it is. Well, the density of the NaCl solution or whatever, so changed as we change concentration. So the density of the sodium chloride solution versus concentration. And I'm just going to title it that just for now. And then I'm just going to select that, and I'm going to change it to Times New Roman font just to make sure that I'm following the rules. And then I want you to take the Figure 1 part and just italicize that for me, just like that. And that's the way I want you to set that up. And then on your y-axis, that was the density. So we're going to label that axis. So if you'll, when you want to change that axis label, I'm about to run out of time on this screenshot I just noticed, so I'm going to pick up just right there. So I only have like 30 seconds left on this part, but not, and I'll just start a new one and pick it up right here in this part right there. Okay, so I'll re-record again more for this one.